Welcome to an intro video all about my course, Computer Science Principles. Students are about to embark on a challenging, fun journey of mental weightlifting and problem solving. This video will give you a general breakdown of what the course entails, my teaching philosophy, and how students are graded. Students work collaboratively in teams to develop computational thinking and problem solving skills. The course does not aim to teach mastery of a single programming language, but aims instead to develop computational thinking to generate excitement about the field of computing and to introduce computational tools that foster creativity. The course also aims to build students' awareness of a tremendous demand for computer specialists and for professionals in all fields. Each unit focuses on one or more computationally intensive career paths. The course also aims to engage students to consider issues raised by the present and future societal impact of computing. Students practice problem solving with structured activities and progress to open-ended projects and problems that require them to develop planning, documentation, communication, and other professional skills. Problems aim for ground-level entry with no ceiling so that all students can successfully engage the problems. Students with greater motivation, ability, or background knowledge will be challenged to work further. Computer science opens doors in any career. Anytime you can say I am blank career with computer science skills, it makes you more marketable. Also, computer science principles aims to answer the big question of how will computing and connectivity transform the world. This course is designed for any students no matter their interests or backgrounds. They can find something to relate to in this class because computers are such a vital part of our lives and future. Everyone should have a sense of how to think computationally. The focus of my teaching involves relationships, inquiry, evidence-based reporting, and technology. Student and teacher professional relationships are the most important thing in my opinion when it comes to learning. Students take more risks, embrace failure and growth, ask more questions when they respect and trust their teacher. Just like a worker would work harder and avoid burnout if they felt appreciated and helped by their boss, I try to do the same thing for students. This involves me getting to know the students on an individual level. Using inquiry-based learning, students practice problem solving with structured activities and progress to open-ended independent inquiry projects and problems that require them to develop planning, documentation, communication, and other professional skills. Each section of this course involves a different focus. The first section involves students being video game creators or computer animators. The next section involves students developing their own mobile apps. It progresses from there with students creating their own data algorithms, solvers, image filters, websites, data analyzers, simulations, among many other things. Grades are only based on mastery of learning standards. Homework, effort, attitude, attendance, etc. are not part of the grade. The only test students will have is a final exam that is composed of all of the concepts in the class. There will be multiple attempts to show mastery using the final exam. The focus for the grade is the end of the course. The focus for the learning is from the beginning until the end. Just like a race, it does not actually matter how you start, it only matters how you end. So if a student is struggling in the beginning of the course but gets it by the end, that's actually all that matters. I'm not going to average the beginning of the course when the students do poorly with the end where they do better, and then it's somewhere in the middle. If they get it by the end, the grade should represent the end, not the average. I use a blended classroom model in which students can learn both in and outside of class. The entire class lives online on my website, so learning becomes ubiquitous. There are many avenues of me connecting with students, such as video, which students can record up to 90 seconds of them asking a question or asking the class questions on my website. Links to online resources that show concepts working conceptually rather than mechanically. Videos that I created so I don't have to lecture in class, allowing me to focus class time on interacting with students one-on-one. These videos kind of allow me to have a co-teacher, which is basically just myself in the form of video. So rather than me lecturing to students, students can actually watch videos as well to get help on whatever they're working on. There's data analysis, which I use a lot to look beyond the numbers, beyond the scores, to find their meaning. Is there a certain question that should be thrown out? Is there a certain question that was unfair? Is there a certain question that if most students that did well on the test, that question is basically that flagship question that shows if you did well on the test, you probably did well on this specific question, as well as online newsletters that I send to parents every 2 to 3 weeks that give parents a personalized view of their students' progress with certain feedback from me. This, among many other things, is how I use technology in my classroom. Again, welcome to my course, Computer Science Principles. If you have any questions about anything in this video, let me know.